Our goal for this project is to optimize a pen manufacturing plant. We will use what we've learned throughout the semester to accomplish this goal in many ways. The problem we have to solve is that we have to create the best method or development of our manufacturing plant to optimize costs, time, and efficiency. We can do that in many ways, like workers' wages, takt time, lead time, and examples like that. First, we have to define the system and all the elements of the system, like the parts that make up the pen, designing the facility layout, how many workers we need, and the process of assembling the pens, and the packing and inspection. Of the elements, there are stuff that we can control and stuff that we cannot control. Things that we control are number of workers, layout of facility, process management. And things that we can't control is like the demand of the product, time, when it is due, and information of the suppliers. Our new process will improve many things like cost to the client, malfunctions of pens, error in shipping, package malfunctions, with such techniques as inspection with one-piece flow. To reach our goals and solve our problems, we have to create a budget for vol pens to be made, create an efficient process, ensure worker specifications are met, and successfully package all of the vol pens, and to make sure that customer demand is met. Of course, we'll have to take into account limitations like space in the facility, hours in a day, and how fast the machines can create the parts. The problem has to be examined through the beginning to the end, the beginning being the manufacturing of all the parts and the end being the final product that is inspected and shipped out. It starts with the manufacturing of the parts. We control the manufacturing of all of the parts that go into a pen. It starts with the plunger, that is automated injection of black, blue, red ink polymer into a plunger casting. Then the ink tube is created from an automated injection of the right color ink inside a polyvinyl tube with a ballpoint on it. And the cap, rubber gripper, barrel, back barrel, and cam are all injected with polymer into the specific mold. All of the polymer injected castings are made from the Engel-Ty-Barless 2012 Husky model plastic injection. Then the springs are made by the CNC spring formel made by Simco. Then the ink is injected into the plastic tube with the ballpoint from the LXP008 PVC injection machine made by Shenzhen. Here's the original master floor plan compared to the actual floor plan. After all of the parts of the pens are made from their respective machines, they are arranged and organized in the arrangement room. Here is the first assembly station. Notice the yellow sticky note that is placed when an assembler runs out of parts he needs to make a pen. That leads us to Kanbans. Kanbans are used to make a plant more efficient and tells us the lead time and how many pens we need to make and basically what needs to be done to a certain batch. Here's the Kanban for a blue pen, and here's one for a black pen. Notice the quantity of 20 compared to the quantity of 10 of this red Kanban pen. Here's the standard operation chart for Station 1 and Station 2. This makes sure that the worker doesn't forget what he's doing. Here's the standard operation of making one pen. This is John Patterson, our fastest worker. We have a right hand and left hand chart to break down the micro motion of all of his motions that he is making to make sure it is the most efficient. Here is the left hand right hand chart that is mentioned before. And here is the flow process chart of the hand motions. It is a little bit more general than the left hand right hand motion, but is still useful into determining the most efficient way to do a process. Here's the operations chart that shows the lower half and upper half of a pen that needs to be done to make a full pen. The next step is the inspection station, which is the final stage, and here is the standard operation chart for the inspection station. Here the pin is moving along the conveyor belt to be inspected. The inspector picks it up, makes sure it clicks, checks to see if it writes, and then he'll eventually put it in the barrel. Once the barrel is full of 20 blue pins, 20 black pins, and 10 red pins, the inspector will seal it and then stamp it to make sure it's verified. Here's a quick overview of the whole process. In order to meet market demand for every month, we have divvied up the amount of hours for each worker, and sometimes they have to work overtime, but overall, the total income to the company is maximized. We have maximized the workspace, making it a streamlined one-piece flow. That cuts down the time to make one pin, and therefore we are able to produce more pins in a given amount of time, therefore making more sales. We installed an assembly line, which made the transport of the pins easier and faster. We also inspected the materials before they were used, which cut down on variation and non-working pins. To make a more happy worker, we gave the assembler more space to assemble pins, we gave him better lighting, and a comfort pad for standing. As they say, a happy worker is a faster worker. We also used gravity-fed buckets that were easier to get materials out of. Then we streamlined the conveyor belt to better fit the facility, which improved lead time and allowed the inspectors to work faster. We can decrease the cost of labor by hiring more experienced workers that can make faster pins, and therefore making more pins per hour and then making the company more money. Here is the new master floor plan that we showed in the video. And here is the new flow process chart. Notice the new inspection step at the beginning. The project provides a better understanding of the process of making the pins and will continue to improve the process throughout working through the new system. In summation, the point of our new process is to streamline production into a one-piece flow. If it's in a one-piece flow, we can maximize the efficiency and decrease the bottlenecks. The recommendations I make is create a one-piece flow, design the facility to better fit the employee comfort levels. If the employees are happy, they'll work better and faster in creating a better product. This is a call for action to create a more efficient plant and maximize efficiency. We will create more pins in a shorter amount of time and have less workers. It is a call for action simply for the company to make more money. Thank you.